Hello. Now we are going to start statistical inference. We're going to do Chapter 8, which is confidence intervals with proportions. Statistical inference for us is going to be making confidence intervals and doing hypothesis tests. So that's what we're going to be doing in essence the rest of the year. And Chapter 8 deals with confidence intervals with proportions. So we're going to be dealing just with proportions this chapter. And the next chapter is going to be tests with proportions. And then after that, we have confidence intervals and tests with mean. So we'll be working with x bar and mu there, but now we're working with p hat and p. So let me remind you of just sort of the couple of concepts that are real important from chapter 7 in regards to this, and what the concept of a confidence interval is. So what's going to happen in each of these problems is we're going to have some population, some whole group of people, animals, or things that we want to know something about. And so let's pretend that this is all the people, all the voting age people in a particular city. And let's just pretend our population size, our big N, is 100,000 people. So that's our population size. And we want to know P, a proportion. The proportion, let's say they're going to vote for a particular candidate, who would say they're going to vote for a particular candidate in an upcoming election. Now, last chapter, sort of unrealistically, they gave us the value of P, but they're not going to do that anymore. What we've got to do is estimate it. And so the way we're going to estimate it is we're going to take a sample. So let's say our sample was of 500 people. Of course, it's very important that we get them randomly, all right? And so we get this little subset of 500 people there. And we come up with the estimate of P, which is P hat. And so in this case, our p hat, let's just pretend that our p hat was equal to 0.37. So 37% of those people. So you had, in other words, in the sample, you had 185. So sometimes it'll give it to you like that. So you had 185 of the 500 that said that they were going to vote for the candidate. So in your sample, you had 0.37. Now, we know, though, even though we got a nice random sample and we didn't have any sort of bias going on, we got 37% in our sample. We know P is almost certainly going to be different from that just because of sampling variability. The only way we could find what P is would be to do a census of all 100,000 people. But we're taking a sample here. We know that if we were to take another sample of size 500, we would probably get a different P hat, just because of sampling variability. So we know this number's probably going to be a little off. And so as opposed to just reporting that number, what we're going to do is we're going to make an interval around that number. We're going to go a little to the left and a little to the right, and then we're going to say we're reasonably confident that P is in that interval. So in this case, and we'll show you how to do this momentarily, but we're going to come up with what is known as a margin of error. And so we're going to add a little bit to the 0.37 with our margin of error. So in this case, it's going to be let's see, it's going to be 0.042. And so if we add that to that, so that is going to give us, like 0.412. And then we're going to subtract from our estimate 0.37 minus our margin of error. And so if we do that, so that ends up being 0.328, I believe. Okay, and so now we have an interval of values, 0.328 and 0.412, where our estimate, our p hat, is right in the middle. And what we're going to say is we are confident, we are reasonably confident, we'll talk about that statement in a minute, that P is in that interval. And so that's what we're going to do this chapter. We're going to find our estimate, and we're going to go a little bit up from the estimate, a little bit down from the estimate, and then we're going to say we're reasonably confident that P is in there. These are the plausible values for P. But what we've got to talk about is finding this margin of error, which is not hard to find, and all the dynamics going on there. And so that is basically sort of the concept of a confidence interval. And so section 8.1, kind of similar to section 7.1, is basically concerned with introductory terminology to the chapter. And then section 8.2 is really the mechanics if you do it with one proportion, and then section 3 deals with the difference in two proportions. So it's kind of similar to chapter 7 in that regard. So this is the basic terminology that goes along with making a confidence interval. First of all, what is a confidence interval? So a confidence interval is in essence an interval of plausible values for a parameter. Our parameters that we're going to work with are P and mu. There's lots of different parameters, but those are the two we work with based on sample data. In other words, based on our p hat and based on our x bar. And so in essence, in the little example we did here, those are the plausible values per p. So we feel like the true proportion of people in the city that is going to vote for this city is probably somewhere in between there, but we're not totally sure. We're reasonably confident. So that's what a confidence interval is. It's our list of plausible values for the population proportion. Now, what is the point estimate? A point estimate is always in the center of our interval, and it is the statistic which estimates a parameter. So our point estimate is going to be your p hat, so your p hat that estimates the p, and the x bar that estimates the mu. And of course, that will actually be in a later chapter when we really work with x bar and mu. So this chapter is mainly with this guy right here, p hat. So when it asks what's the point estimate, it's just the value that is right in the middle of your interval, which in this case is 0.37. It's always going to be right in the middle of the interval. It'll be your statistic. Okay, and so then we have what did I just say? Okay, where's the point estimate always going to be? In the middle of your interval. So if it gives you an interval and it asks what's the point estimate, just find the midpoint of that interval. Okay, the next thing, here's our formulas. Okay, so your generic formula, and this is on your formula sheet. If you go to the first page of your formula sheet, and so it says it right there, confidence interval, what it is, it's your statistic or your point, otherwise known as your point estimate, plus or minus what we're going to call our critical value times the standard error of the statistic. And so that's what we're going to talk about momentarily. There's your generic formula. So then for a proportion, here is how that works out. Now, if you turn to the second page of your formula sheet, so for well, let me come back to that. I'm sorry. So but anyway, so here is the formula for the confidence interval for proportion. So our statistic is p hat, so that will go there. Our critical value is what we call z star. It is in essence the number of standard errors that we're going to go to the left and to the right from our center. And then that is the formula for our standard error. You'll notice that it is the formula for the standard deviation of a sampling distribution, but we don't know p until we have to use p hats in its place. And so that's what I was sort of getting at here when it says, okay, the standard error of the sample statistic, so that's right there for a proportion. So, and we'll talk momentarily how to find the z star. And then for a mean, now this we're really not going to use this formula until a later chapter when we work with means, but that's the formula there. T star you don't have to worry about now, and then S is the standard deviation of the sample. Remember in chapter 7 we had sigma over the square root of n. Well, we don't know sigma. We have to use the standard deviation of the sample over the square root of n. So those are our basic formulas, but this is the one that you really need to be able to use in this chapter, and we're going to do an example in a minute. So what are these? All right, they're critical values. Like I said, they're the number of standard deviations we're going to the left and to the right. And you can find them using your tables or using your calculator. And so they're based, in every problem, you're going to be given a confidence level. You're going to be given, it'll say create a 95% confidence interval, or create a 90% confidence interval, or 99% confidence interval. What you're going to do to find your critical value is you're going to go to table B in your tables where it says t-distribution critical values, but it includes the z ones as well. And you're going to go to the bottom of the table, and this isn't the best copy here. But on the bottom of the sheet, you'll notice it has these percents, confidence levels, that will in essence be given to you in the problem. And so for a 95% confidence interval, you're going to go up right here, and that's your confidence. That is your critical value for 95%. It's next to the infinity sign, and we'll talk about that at a later time. So the z star for 90% is that, 1.645, and the z star for 99% is that. And so it would be 2.576. And so here's all the ones you could really probably ever need. Those are the only ones that have been on the exam. I'm going to show you how to use a calculator to find it momentarily, but anyway, so it's just easy to get right off the table. So you just, anyway, I mean, like I said, you'll be given the confidence level. So then the standard error. So the standard error, which is just this part of this formula, is right there. And like I said, that formula is on your formula sheet. It is basically the standard deviation of the sampling distribution we talked about last chapter. The square root of p hat times 1 minus p hat over n. The reason we call it standard error is, as opposed to standard deviation, it's sort of the same concept, but it is the fact that we don't know what P is, and so we're using an estimate. And so whenever you use an estimate to plug in, we call that an error. It's not an error in the sense that anything's being done wrong. It's just we don't know this exact value, so we're using an estimate there. And the same thing here. We don't know what sigma is, so we have to use S in its place, so we call it the standard error. And so that is that. The margin of error. And so the margin of error is basically how much the interval is going to the left and to the right, like we demonstrated before. And it is this here and this there, in essence. And so there's the margin of error. It is critical value times standard error. So it's Z star times that. And then for a mean, it's T star times S over the square root of N. But that is for a future chapter. So let's talk about an example right quick. So like, let's say, going back to that scenario we were just in where we had, we wanted to estimate P, the proportion of all the people in the city that are going to vote, that say they will vote for a particular candidate. So we want to estimate that number. So we took a sample of 500 people, and we find that 185 of them say that they are going to vote for the candidate. And so that means our point estimate, our P hat, is going to be equal to 185 over 500, and that's equal to 0.37. Then we are told to create a 95% confidence interval. You will be given that in basically every problem. Create a 95% confidence interval for P. Okay, that is your estimate, but create a 95% confidence interval for what you think P is. And so what we'll do, and so that our formula for that is our estimate plus or minus our Z star critical value times our standard error, the square root of P hat, times 1 minus P hat over N, like that. And so we would say, okay, for 95%, I will go to 95% here on the bottom of table B. The Z star that goes with that is 1.96. So, of course, this right here is 0.37 plus or minus 1.96. And then the square root of, and that's 0.37 times 0.63 over 500. And so that ends up 0.37. And so that ends up being plus or minus 0.042319. And so our confidence interval, doing a little rounding here, so 0.37 plus that is 0.412, and then 0.37 minus that is 0.328. And so that is our confidence interval. And our conclusion that we're going to draw is we're going to say we are 95% confident that P is in that interval. We don't know what P is, but we are 95% confident that it is in that interval. And this, it once again goes back to the empirical rule. See, what we're doing here, you may have noticed, we're going out, in essence, 2 standard errors or in effect, 2 standard deviations, and we have normality here. And we'll talk about, because N times P and N times 1 minus P are greater than or equal to 10, like we talked about last chapter. And so since we have a normal curve, if you go out 2 standard deviations, it's going to capture 95% roughly of your distribution. And so what we've done is we've gone out 2 standard deviations from our sample value, or almost 2 standard deviations. And so we can say, hey, we're 95% confident that actually captures the true value of P. Because, the way we talked about it before is that if we knew what P was, we're 95% confident our P hat was within 2 standard deviations of it. But the reverse of that goes as well, is that if we go out 2 standard deviations from our P hat, we're 95% confident that P is in there. And so that's how you make a confidence interval. This number right here, and you could and will be asked this. You'll be asked, what is the margin of error? That is it. That is your margin of error. You'll be asked, what's your standard error? That is it. That is your standard error. You'll be asked, what is your critical value? That is it, right there. And so those are the kind of questions you're going to be asked on your test that you need to be able to answer. Okay, a couple of important things. What is the conclusion that we draw from this? What is the conclusion we draw? In other words, if you were asked to interpret an interval, to interpret this interval, which in fact I just did, to interpret the interval means that you're going to say, I'm 95% confident that P is in there, or I'm 95% confident that this interval captures P, the proportion of all of the people in the city that would say they're going to vote for this candidate. So that's the next thing on our little sheet. What does it mean to interpret a confidence interval? Is you're just going to say whatever, and you're going to say, I am whatever percent confidence listed in the problem. If it said in the problem, create a 99% confidence interval, then create a 90, and then you would say, I'm 99% confident. So in this, you would say, I am, whatever your confidence level, I am that percent confident that this interval captures the parameter, and then define what that parameter is. So if it's, if you're estimating the percent of students that make above a 30 on the ACT, then you're going to say, I'm 95% confident that this interval captures the parameter P, the proportion of all the students that made above a 30 on the ACT. Okay, that's what it means to interpret the confidence interval. Don't get that confused with what is known as interpreting the confidence level. Interpreting the confidence level means this. If we were to do this same procedure many times and made many different intervals, 95% or whatever your confidence level is of the intervals would capture the parameter. Let me explain what I mean by that. So let's say, for instance, okay, let's look at this. So let's say if we have a population parameter P that we're asking, we make a confidence interval. And so we get a P hat that's like right here, okay? And we go out, like in this case, it's a 90, we're given 95% confidence. So we got basically 1.96 or 2 standard errors. There's our interval. But if we were to take another sample and to make another interval, we would almost certainly get a different P hat because of sampling variability, and we would get a different interval. Okay, and if then we were to take another sample and make another interval, we would get another P hat. This one also, you notice, it captures the true proportion, okay? And if we made many different intervals, we would get many different P hats and get many different intervals as we go down. And most of them are going to be around P because I'm doing this in an unbiased way, just different intervals. The P hats are going to vary, but every once in a while, this is going to happen. I just happen to get a P hat that's way out on the tail of the sampling distribution in essence, and it does not capture P, just by chance. Just by chance that happened. Not that my P hat was a lot more than P here, just by chance. And so what this is if all possible samples, if we did many, many different samples and created many, many different intervals, 95% confidence means 95% of these intervals would actually capture P. And 5%, like this guy here, would not capture P. If we did 99% confidence, what that means is this. If we made many, many different intervals, 99% of the resulting intervals would actually capture P. So that's what confidence level, when you're asked to interpret the confidence level, and that's something that you have to memorize and you have to understand that is frequently asked. So, okay, thank you for paying attention. I wish you much success in confidence intervals.